Hello everyone, my name is Naveen Kumar and I am faculty of physics at Rawat Public School. I hope everyone is fit and fine. Now, in this video we will learn about a relationship between current and drift velocity, and with the help of that relation we will deduce Ohm's law. Okay, so this is quite important topic. Let's suppose we are having a conductor. The length of this conductor is L and area of cross section of this conductor is A. We have applied a battery to this conductor, and because of that a current starts flowing into the conductor, into this wire, and let's suppose that current is I. Okay, now number of electrons in that conductor per unit length, we say L, and that is N, number of electrons per unit length. So in the entire volume of this conductor, how many electrons were present? Electrons in entire volume. Okay, so it is NaL. Okay, N is the number of electrons per unit length, and A dot L, A is area of cross section, and L is the length. So this is NaL is the number of electrons present in entire volume. So with the help of quantization concept we can calculate the amount of charge. Okay, the amount of charge into this entire conductor, and that is number of electrons, that is NaL, multiply with charge of a single electron, that is E. So यहाँ पे चार्ज कितना आ गया? NeAl, हम ये देख सकते हैं. Okay, now these electrons will take some time from here to here to reach, and they will move with some velocity. So let's suppose time is equals to, by using the simplest formula, speed is equals to distance upon time concept. So time here is, we can calculate with the help of this formula, speed is equals to distance upon time. So time is distance divided by speed. So these electrons are moving with drift velocity, average velocity with which these electrons are moving, and they are covering a distance L, and speed here is vd. Okay, so यहाँ पर टाइम का फॉर्मूला क्या आ गया? T is equals to L upon D. Okay, now we are having two things, one is charge, second one is current. So with the help of these two things we can calculate the current. Current क्या होता है? That is Q divided by T, that is rate of flow of charges, Q by T. Substitute value of this Q and T here in this expression. So Q is NeAl divided by T, that is LVD. Okay, now L is present in both in numerator as well as denominator, so we can cancel out it, and this VD we can bring it into the numerator. So this is NeAVD. So we got an equation for the relation between electric current and drift velocity, and that is I is equals to NeAVD. Now just see the terms. I is current here, N is the number of electrons, E is charge of a single electron, A is a cross section area of this conductor, and Vd is the drift velocity with which these electrons are moving. Okay, so with the help of this relation we can deduce Ohm's law. Sometimes in the examination the examiners are asking like, deduce Ohm's law with the help of drift velocity and the current. Okay, and what is the Ohm's law in terms of relaxation time? Okay, so we can deduce with the help of this expression. So let us do that. Deduction of Ohm's law. Okay, now one concept we will be using, that is relation of potential and electric field. We studied this thing in the second chapter, E is equals to V divided by L, and this Vd is equals to small e capital E tau divided by M. This small e is charge of a single electron, capital E is applied electric field, and tau is relaxation time, and M is mass of electron. Substitute value of capital E. So this Vd is equals to E V tau divided by ML. Okay, so this is Vd is equals to E V tau divided by ML. We substituted value of electric field here in this expression. Okay, now with the help of previous derivation, we know the relation between electric current and drift velocity, that is I is equals to ANE Vd. Vd is drift velocity. This we know. Okay, now substitute value of Vd, that is drift velocity. This is ANE E capital E tau divided by ML. Okay, now we can solve it further. I is equals to substitute value of Vd, that is ANE EVL V tau divided by ML. Okay, so I is equals to A N E square V dot tau divided by ML. Okay, this bring this V in the denominator of I. So this is I divided by V is equals to A N E square tau divided by ML. Now we know that I divided by is what? This is reciprocal of resistance. So this is 1 upon R is equals to ANE square tau divided by ML. So here this R is resistance. So this is, we reverse the terms, ANE square tau. This is Ohm's law deduced with the help of this formula, I is equals to ANEVD. Now in the same way we can here calculate the value of resistivity in terms of all these parameters. Okay, now one more thing, when we keep the physical quantities constant, at this temperature and the pressure, then all these parameters will remain constant, that is M, A, E square, tau, and all these parameters remain constant, and that time that resistance is M L divided by A and E square by tau. Okay, now by this expression we can find out one more relation, that is of drift and that resistivity. Rho R is ML divided by A and E square tau. Okay, now resistivity formula that we know, R is equals to rho L divided by A. This is, let's suppose this is equation number 1 and this is equation number 2. Okay, equate 1 and 2. So we can see here ML divided by A and E square tau is equals to rho L divided by A. Okay, now this LA, so here resistivity is M divided by N E square tau. Now you can see here in this formula, this resistivity is independent of the shape and size. There is no term related to length and there is no term related to area. It depends entirely on the material, okay, that we are going to use. Thank you.